In the old world of Silicon Valley, software companies climbed like mountaineers, slow, expensive, carefully paced. Startups spent years hiring sales teams, building enterprise relationships, surviving funding winters, and crawling toward profitability one subscription at a time. Then, Cursor arrived like a meteor entering the atmosphere sideways. According to Bloomberg, the AI coding startup Cursor reached a reported $2 billion annualized revenue run rate by February 2026, after doubling revenue in just 3 months. Days later, additional reporting from investing.com, citing Bloomberg, claimed the company crossed an astonishing $3 billion annualized revenue run rate by late April 2026. The numbers sounded less like software economics and more like a physics experiment gone unstable. As reported by Forbes, Cursor was founded in 2022 by Michael Truell and 3 MIT classmates. At first glance, the company seemed deceptively simple, an AI-enhanced code editor that helped programmers write software faster. But underneath that modest pitch was something far more disruptive. Cursor was not selling software in the traditional sense. It was selling acceleration itself. Developers no longer had to memorize every syntax rule or manually navigate giant codebases. They could increasingly describe what they wanted in plain English, while the machine generated, edited, debugged, and sometimes even reasoned through the code for them. The keyboard was becoming less of an instrument and more of a steering wheel. According to TechCrunch, Cursor's enterprise customers eventually accounted for roughly 60% of its revenue, signaling that AI coding tools had moved beyond hobbyist experimentation into the corporate bloodstream. Investors responded with the kind of frenzy normally reserved for gold rushes and wartime resource discoveries. The Wall Street Journal reported that Cursor reached a valuation of roughly $29.3 billion after a massive funding round in late 2025. But beneath the excitement sat a dangerous question humming quietly through Silicon Valley. Was Cursor building the future operating system for human programmers? Or was the entire industry witnessing the fastest inflation of a developer tools bubble in modern tech history? Because when revenue charts start looking like rocket launches, gravity eventually enters the conversation.
Before Cursor, coding had already begun to change. Cursor did not emerge from a vacuum. Long before AI-generated code flooded Silicon Valley timelines, programming itself had already been evolving into something more abstract, more automated, and strangely more conversational. For decades, software engineering resembled industrial craftsmanship. Developers manually stitched together logic line by line, navigating cryptic documentation, debugging obscure errors at 3 a.m. beneath the fluorescent glow of computer monitors. Early developer tools focused mainly on efficiency. Autocomplete systems predicted variable names. Cloud-based IDEs allowed engineers to work from anywhere. GitHub transformed collaboration into a global assembly line for code. Then the language models arrived. According to Reuters, the rise of generative AI after ChatGPT fundamentally altered how software could be created, turning coding into one of the first industries where AI demonstrated immediate commercial usefulness at scale. GitHub Copilot helped normalize the idea that AI could suggest entire blocks of working code. But the real psychological shift came later, when developers realized they no longer needed to code in the traditional sense at all. They could simply describe intentions, build a login system, fix this bug, create a dashboard, refactor this database query. The machine would respond not with search results, but with functioning software. As reported by Reuters, major technology firms like Google and Microsoft were already generating significant portions of their internal code with AI systems by 2025. The act of programming was quietly transforming from manual construction into supervision. Engineers increasingly became editors, orchestrators, and decision-makers, rather than pure builders. That shift created the perfect conditions for Cursor's explosion. According to Forbes, Cursor succeeded partly because it wrapped advanced AI capabilities inside a familiar developer environment built around the habits programmers already understood. Developers did not need to relearn everything. The future arrived disguised as a better text editor. Online discussions across Reddit and SaaS communities described the phenomenon almost like a cultural mutation. Developers began using phrases like vibe coding, referring to a workflow where human intention mattered more than technical implementation. In other words, by the time Cursor appeared, the industry had already been softened by years of automation. Cursor simply arrived at the exact moment when programmers were psychologically ready to hand more responsibility to the machine. And once that door opened, it did not open halfway. Beyond the headline, beyond Cursor's explosive revenue numbers, a larger battle is unfolding across the AI developer tools ecosystem. According to Reuters and TechCrunch, competitors including Anthropic's Claude Code, OpenAI's Codex, Replit, Cognition, and Lovable are racing to dominate what many investors believe could become one of the most valuable software markets of the decade. At the same time, skepticism is growing. Multiple Reddit discussions and analyst conversations question whether companies like Cursor can maintain profitability while relying heavily on expensive foundation models from OpenAI or Anthropic. Others argue the bigger story is not Cursor itself, but what its growth reveals about AI-native companies, extremely small teams generating unprecedented revenue per employee. The debate now stretches far beyond coding tools. It is becoming a referendum on whether AI permanently rewrites the economics of human labor in software.
Chapter 3: The MIT Founders and the Birth of Anysphere. In most startup stories, the founders begin with a business plan. The Cursor story began with irritation. 4 students at the Massachusetts Institute of Technology looked at modern software development and saw friction everywhere. Endless debugging, constant context switching, engineers drowning beneath tabs, documentation, terminal windows, and sprawling code bases that seemed to expand faster than humans could mentally contain them. While much of Silicon Valley was still debating whether AI coding assistants were gimmicks or genuine infrastructure, these students quietly arrived at a more radical conclusion: programming itself was about to be reinvented. According to TechCrunch, Michael Truell, Swale Asif, Arvid Lunenmark, and Aman Sanger founded Anysphere in 2022 while still connected to MIT. Their shared goal was not simply to build another autocomplete plugin, but to create what they described as an AI-native software development environment. That phrase mattered. At the time, most AI coding products behaved like add-ons bolted awkwardly onto existing editors. Cursor's founders believed that approach fundamentally misunderstood where the technology was heading. According to interviews cited by Business Insider and The Verge, the team believed developers would eventually collaborate with AI systems continuously throughout the coding process, almost like working alongside an invisible engineering partner. The distinction sounds subtle, but it changed everything. Autocomplete predicts your next sentence. Collaboration changes how you think. According to TechCrunch, Aman Sanger explained early on that competitors had already handled autocomplete reasonably well, while Cursor wanted to focus on what came after autocomplete: debugging, understanding entire codebases, answering architectural questions, and fixing problems across multiple files simultaneously. That philosophy pushed Anysphere toward a far more ambitious vision. The founders were not trying to make developers type faster. They were trying to reduce the amount of software humans needed to manually reason through in the first place. According to MIT News, Truell described the company's mission as making programming an order of magnitude faster, more fun, and creative. News.mit.edu. In Silicon Valley, timing often matters more than perfection, and Anysphere launched precisely as large language models crossed an invisible threshold from novelty to utility. Developers who once mocked AI-generated code suddenly found themselves using it daily. Entire workflows began mutating in real time. According to Forbes, Cursor's rise became so rapid that companies including Instacart and Samsung adopted the tool while the startup was still extraordinarily young. But internally, the company still operated with the intensity of a research lab more than a polished enterprise software giant. According to Business Insider, the founders emphasized intellectual curiosity, experimentation, and small elite teams obsessed with building the future of programming itself. The irony was almost cinematic. 4 students initially dismissed by many as building an AI coding toy were suddenly shaping how millions of developers interacted with software creation. And by the time the rest of the industry realized the shift was real, Anysphere already had a massive head start. Chapter 4: The product that developers couldn't stop sharing. Software products usually grow through marketing funnels, enterprise contracts, and aggressive sales campaigns. Cursor spread more like a whispered secret passed between programmers at 2 in the morning. One developer would post a video generating an application in minutes. Another would demonstrate the AI rewriting thousands of lines of code across multiple files without breaking the project. Soon, social media feeds and engineering forums filled with stunned reactions from programmers watching tasks that once consumed entire afternoons collapse into minutes. According to TechCrunch, Cursor was built as a fork of Microsoft's Visual Studio Code, allowing developers to keep familiar workflows, extensions, and themes while layering AI directly into the editing experience. That design decision removed one of the biggest obstacles in software adoption, forcing users to abandon habits they already trusted. The AI features themselves felt unusually fluid compared to earlier coding assistants. According to multiple industry reports, Cursor could search entire repositories, explain unfamiliar code, debug problems, rewrite multiple files simultaneously, and execute semi-autonomous agentic workflows that resembled delegating work to a junior engineer rather than querying a chatbot. Developers were no longer interacting with isolated code suggestions. They were interacting with systems capable of understanding broader project context. According to the Wall Street Journal, much of Cursor's growth came organically through developer enthusiasm rather than traditional enterprise sales infrastructure. In the programming world, recommendations spread with unusual force because engineers constantly exchange tools that improve productivity. One viral demonstration inside a company can trigger adoption across entire teams almost overnight. That dynamic created a feedback loop powerful enough to rival paid marketing campaigns. As reported by the Financial Times, Cursor users were generating nearly 1 billion lines of code per day by 2025 through natural language prompts. The product also benefited from a deeper cultural shift happening inside software engineering itself. Developers increasingly embrace what former Tesla AI director Andrej Karpathy famously called vibe coding, where programmers guided systems conversationally instead of manually constructing every detail. Cursor became one of the first tools designed explicitly for that emerging workflow. And that may have been Cursor's greatest breakthrough. It did not merely help developers code faster, it made programming feel different. Chapter 5: The Rise of Vibe Coding. Programming once demanded ritualistic precision. A missing semicolon could collapse an application. A misplaced bracket could send developers spiraling through hours of debugging. For decades, software engineering functioned almost like a priesthood, guarded by syntax, mathematical logic, and years of technical training. Then AI began translating human intention directly into code, and suddenly programming started feeling less like engineering and more like conversation. The term vibe coding, popularized by former Tesla AI director Andrej Karpathy, emerged as shorthand for a strange new workflow where developers simply described what they wanted in natural language, while AI systems generated the underlying implementation. According to social media posts and interviews cited by tech publications, Karpathy described the process as giving fully into the vibes and letting AI handle large portions of the actual coding work. The phrase sounded playful, the implications were not. According to Reuters, the rapid improvement of large language models transformed software creation into one of the first major industries where AI demonstrated immediate real-world productivity gains. Developers increasingly stopped memorizing syntax because the machine already knew it. Instead, the valuable skill became articulation, knowing how to describe systems clearly, knowing how to structure intent. Prompting began replacing typing. Cursor became one of the defining products of that shift. Users could ask the AI to build authentication systems, redesign interfaces, debug broken repositories, or refactor entire projects using plain English instructions. According to the Wall Street Journal, developers increasingly interacted with Cursor less like a text editor and more like a collaborative engineering assistant capable of reasoning across entire code bases. The barrier to entry for software creation collapsed almost overnight. People with minimal programming experience suddenly found themselves building websites, internal tools, games, and startup prototypes they previously lacked the technical ability to create. Online communities filled with stories of designers, marketers, and entrepreneurs shipping functional applications after only weeks of experimentation with AI coding tools. According to Reddit discussions surrounding Cursor and Replit workflows, many users described the experience as creative empowerment, comparing it to the way Canvas simplified graphic design or how smartphones democratized photography. But excitement traveled alongside fear, because if software creation becomes conversational, then the scarcity value of traditional coding expertise changes dramatically. Critics warned that vibe coding encouraged shallow understanding. AI-generated applications often appeared functional while hiding security vulnerabilities, architectural flaws, or maintenance nightmares beneath the surface. According to reports from engineering forums and industry analysts, many experienced developers worried that a generation of AI-assisted builders might ship products they did not fully understand. And yet the momentum continued accelerating, because history rarely pauses for professional discomfort. The spreadsheet did not eliminate accountants. The camera did not eliminate artists, and AI coding tools were unlikely to eliminate software creation itself.
Instead, they appeared to be redefining who gets to participate in it. For the first time in computing history, programming was beginning to shift from a technical language humans learn from machines into a human language machines learn from us.
Chapter 6: From Indie Hackers to the Fortune 500. At first, Cursor spread through the internet's underground corridors. Indie hackers used it to launch side projects at impossible speed. Startup founders generated prototypes over weekends. Developers posted viral demos showing applications assembled in hours instead of weeks. The product moved through engineering culture the way underground music scenes spread before streaming platforms discovered them, organically, chaotically, person to person. Then, corporations started paying attention. According to Reuters, AI coding assistants quickly evolved from experimental developer tools into enterprise productivity systems, as companies realized they could accelerate software output while reducing engineering bottlenecks. The shift changed Cursor's trajectory entirely. Consumer enthusiasm created visibility. Enterprise adoption created hypergrowth. According to Bloomberg and TechCrunch reporting, Cursor's enterprise business rapidly expanded as large organizations rolled out AI coding tools across engineering departments. Companies no longer view AI coding assistants as novelty software. They viewed them as productivity infrastructure. And once executives started measuring engineering velocity, the economic argument became difficult to ignore. If developers could ship products faster, fix bugs faster, understand unfamiliar repositories faster, then AI coding assistants directly impacted revenue timelines. According to Forbes and multiple venture capital analyses, Cursor's growth accelerated dramatically as enterprise customers generated recurring subscription revenue at massive scale. Instead of convincing millions of consumers individually, Cursor increasingly focused on convincing entire organizations at once. The product itself also evolved to match corporate demands. Security controls improved, team collaboration expanded, administrative tooling matured. According to Financial Times reporting, large companies increasingly wanted AI systems capable not only of generating code, but understanding massive internal repositories containing years of accumulated software logic. That requirement favored tools like Cursor, which specialized in repository-wide reasoning rather than isolated autocomplete suggestions. By 2025, the numbers surrounding enterprise adoption began sounding almost surreal. According to reports cited across industry publications and investment analyses, developers at more than half of Fortune 500 companies were reportedly using Cursor or experimenting with its workflows internally. Inside corporations, the psychology around AI also shifted. Initially, many executives feared AI coding tools would introduce risk. Later, they feared competitors adopting them first. That distinction changed everything. Because once AI became associated with productivity gains, refusing adoption started looking less like caution and more like strategic paralysis. The result was a feedback loop unlike anything traditional SaaS companies had experienced. Developers brought Cursor into companies organically. Companies standardized usage internally. Enterprise contracts expanded revenue explosively, and every new deployment generated more internal pressure for competitors to adopt similar systems. The software industry had entered an arms race where speed itself became the product, and Cursor, at least temporarily, stood directly at the center of it. Chapter 7: The Most Valuable Employees in Silicon Valley. In the industrial age, scale meant armies. Factories needed thousands of workers. Retail giants needed sprawling logistics networks. Even the first generation of internet companies depended on enormous employee bases to sustain growth. Silicon Valley's largest software firms became corporate megacities filled with recruiters, product managers, marketers, lawyers, analysts, and engineering departments large enough to resemble small countries. Then, companies like Cursor introduced a terrifying new possibility. What if the next trillion-dollar businesses needed only a few hundred people? According to reports from The Information and Reuters, Cursor's parent company, Anysphere, operated with a remarkably small workforce while generating revenue figures that rivaled mature public software firms. Online analysts began calculating the company's implied revenue per employee, and the numbers sounded almost absurd. In some estimates circulating across venture capital circles, Cursor appeared to generate millions of dollars annually per worker, dramatically exceeding the ratios historically associated with companies like Salesforce or Google. The economics looked less like SaaS and more like science fiction. According to Bloomberg, investors increasingly viewed AI-native startups as fundamentally different from previous generations of software companies, because AI systems themselves could automate large portions of operational work once handled by humans.
Customer support could be AI-assisted. Code generation could be partially automated. Internal tooling could be built by tiny engineering teams. Marketing content could increasingly be machine-generated. Entire layers of traditional organizational structures suddenly looked optional. The consequences extended far beyond Cursor. According to Reuters, venture capital firms began aggressively funding startups built around extremely lean headcounts, betting that generative AI would permanently alter the relationship between labor and revenue generation. Inside Silicon Valley, a new fantasy began circulating through boardrooms and investor dinners, companies with fewer than 1,000 employees eventually reaching trillion-dollar valuations. For decades, technology promised leverage. AI appeared to multiply that leverage exponentially. But hidden beneath the excitement was an unsettling implication. If tiny teams could generate enormous economic output, then what happens to everyone else? Because every chart celebrating revenue per employee contained another story lurking invisibly in the background. Fewer employees might simply be required in the first place. And Silicon Valley, for all its optimism, has rarely been sentimental about efficiency.
Chapter 8: The AI Arms Race for Developer Dominance. Once investors realized AI coding assistants were not a niche curiosity, but one of the first generative AI products capable of producing immediate economic value, the entire industry stampeded toward the same battlefield. The war for developer dominance had begun. According to Reuters, coding assistants rapidly became one of the hottest sectors in artificial intelligence because the value proposition was unusually clear. Unlike experimental AI products searching for practical use cases, developer tools produced measurable productivity gains almost instantly. Faster software development translated directly into money. Every major AI company wanted ownership of that future. GitHub Copilot, backed by Microsoft and OpenAI, helped pioneer AI-assisted programming at scale. According to Microsoft, millions of developers eventually adopted Copilot as AI-generated coding suggestions became normalized inside engineering workflows. But competitors quickly pushed beyond autocomplete. Anthropic focused heavily on reasoning-oriented coding systems powered by Claude models, which many developers praised for handling large code bases and complex debugging tasks. OpenAI expanded deeper into coding agents and autonomous software generation. Replit emphasized browser-based collaborative programming environments, where AI became embedded directly into the development process. Lovable targeted rapid application generation through conversational prompts, appealing to a growing wave of non-traditional programmers and startup founders. Each company carried a different philosophy about what programming would become. According to The Verge, some AI labs envisioned a future where developers remain deeply technical architects, supervising increasingly capable AI systems. Others imagined programming becoming radically democratized, where natural language itself evolved into the dominant interface for software creation. The distinctions mattered because they implied entirely different futures for human labor. In one version of the future, engineers become exponentially more productive. In another, many traditional programming tasks become partially automated commodities. According to Financial Times reporting, venture capital funding flooded aggressively into AI coding startups, precisely because software development sits at the center of nearly every modern industry. Whoever controlled the interface between humans and software creation could potentially control one of the most valuable layers of the global economy. And unlike earlier platform wars, this battle moved at terrifying speed. Features copied features within weeks. Models improved monthly. Startups reached billion-dollar valuations before most consumers even recognized their names. Meanwhile, developers themselves became both the customers and the battleground. Online communities across Reddit, Hacker News, and X filled with endless comparisons between Claude, Cursor, Copilot, Windsurf, Replit, and OpenAI tools. Workflows evolved almost faster than tutorials could document them. The industry was no longer competing to build software tools. It was competing to become the operating system for human thought itself. Because if AI eventually writes most code, then the company controlling the AI may ultimately control how the digital world gets built.
Chapter 9: The Dirty Secret Behind the Boom. From the outside, the AI coding boom looked like a financial miracle. Tiny teams, explosive growth, multi-billion-dollar valuations, revenue charts climbing vertically like launch trajectories leaving Earth's atmosphere behind. But beneath the spectacle sat a quieter reality hidden deep inside server farms and GPU clusters. Every AI-generated line of code cost money, sometimes enormous amounts of money. According to Reuters, many AI coding startups depended heavily on foundation models from companies like Anthropic and OpenAI, paying substantial inference costs every time users generated, edited, debugged, or analyzed software through their platforms. Unlike traditional SaaS products, where software could often scale cheaply after initial development, generative AI products consumed expensive computational resources continuously. Every prompt triggered massive infrastructure systems involving GPUs, energy consumption, networking, and model serving costs. In simple terms, growth itself became expensive. According to the information, some AI startups faced mounting concerns about gross margins because usage costs scaled aggressively alongside user engagement. In older SaaS businesses, heavy usage from customers was usually a dream scenario. In generative AI, power users could become financially dangerous if monetization failed to outpace compute costs. That created a strange contradiction at the center of the boom. The more successful these products became, the more infrastructure they consumed. Some investors began privately comparing the situation to subsidized ride-sharing economics during Uber's early expansion years. The assumption was that model costs would eventually fall fast enough for margins to stabilize. But that assumption remained uncertain. According to SemiAnalysis and multiple industry reports, advanced AI inference remained extraordinarily expensive even as hardware improved. Training frontier models required billions of dollars in infrastructure investment, while serving millions of users demanded constant access to cutting-edge GPUs, often controlled by only a handful of cloud providers. This introduced another hidden vulnerability. Many AI startups did not fully control the core intelligence powering their products. Companies like Cursor built remarkable interfaces and workflows, but underneath, they frequently relied on models owned by OpenAI or Anthropic. That dependency meant pricing changes, API restrictions, or competitive pressure from model providers themselves could radically reshape the economics overnight. According to Financial Times reporting, some analysts questioned whether the current market resembled the early internet boom, where revolutionary technology existed alongside wildly inflated expectations and fragile business fundamentals. Still, optimism remained intoxicating because even critics acknowledged one uncomfortable fact: these tools genuinely worked. Developers were shipping products faster, companies were automating workflows, AI-generated software was no longer theoretical. The technology was real. The question was whether the economics were real too.
Why investors started throwing billions at Cursor. In the modern venture capital machine, conviction rarely arrives gradually. It detonates. And Cursor became one of those detonations. According to TechCrunch and CNBC reporting on AI coding startups, Cursor's valuation surged toward the $50 billion range in early 2026, after previously being valued at roughly $29.3 billion just months earlier in late 2025. The speed of that leap stunned even seasoned investors, not because software companies had never grown fast, but because very few had ever rewritten their entire economic category while still scaling revenue at the same time. According to Reuters, Cursor's annualized revenue crossed the multi-billion-dollar mark within roughly a year of rapid enterprise adoption, placing it among the fastest-growing B2B software platforms in history. For investors, this was not just growth. It was compression of time itself. What changed everything was the belief that Cursor was not a tool, but a layer, a new operating environment for software creation. According to Andreessen Horowitz analyses of the AI software stack, coding assistants increasingly sit at the application layer of intelligence, meaning they are positioned directly between human intent and machine execution. In that framing, whoever owns that layer effectively controls how software is produced across industries. That idea triggered a familiar Silicon Valley reflex. If something becomes infrastructure, it becomes winner take most. Investors began comparing Cursor not to SaaS tools like Jira or Slack, but to operating systems and cloud platforms. Because if every developer interacts with AI while writing code, then the interface they use becomes just as important as the models underneath it. According to CNBC and TechCrunch reporting on the funding frenzy, major firms including Andreessen Horowitz, Thrive Capital, Excel, and others reportedly competed aggressively to back Cursor's next funding rounds, often citing fear of missing the defining layer of the AI economy. The logic was brutally simple. If AI is rewriting software development, then the companies controlling AI-assisted development will sit at the center of global software creation. And investors, historically allergic to missing platform shifts, responded the only way they know how,
by accelerating the shift with capital. Chapter 11: SpaceX, Compute Power, and the Battle for AI Infrastructure. As Cursor scaled, a different kind of constraint began shaping its trajectory. Not demand, not product, not even competition. Compute. Modern AI coding systems depend heavily on foundation models and infrastructure provided by a small number of AI labs. According to Reuters reporting on the AI ecosystem, many coding startups rely on external model providers, such as OpenAI and Anthropic, making access to compute both a cost center and a strategic dependency. In other words, Cursor may own the interface, but it does not fully own the intelligence. That distinction matters more every quarter. As AI workloads expand, the industry is increasingly defined by a scarcity of GPUs, data center capacity, and model access. According to Reuters' coverage of model labs and similar infrastructure companies, demand for compute has surged so dramatically that revenue in AI infrastructure startups has scaled from tens of millions to hundreds of millions within a single year. Compute is no longer background plumbing, it is the bottleneck. This is where the narrative surrounding Cursor becomes unusual. According to reporting from the New York Times and other outlets, SpaceX was linked to discussions involving a potential strategic stake or option tied to Cursor, with figures circulating in the tens of billions range. While details remain partially speculative in public reporting, the implication reflects a broader truth. Compute power and distribution are becoming as strategically valuable as ownership itself. SpaceX's role in the AI ecosystem is not just about rockets or satellites. It represents access to global infrastructure networks that can support next-generation computing demands. In a world where AI agents continuously generate and execute code, bandwidth, latency, and distributed compute matter as much as raw model intelligence. The AI industry is quietly splitting into three power centers: model creators like OpenAI and Anthropic, infrastructure providers controlling compute and distribution, and application layer companies like Cursor trying to sit on top of both. According to academic studies on agentic coding systems, tools like Cursor increasingly function as collaborators in software development workflows, initiating pull requests and handling complex tasks, while humans retain final approval. That means usage scales not linearly, but explosively, because every additional task can trigger multiple AI-driven operations underneath. Which leads to a paradox. The more useful Cursor becomes, the more compute it consumes. And in the AI economy, consumption is cost, dependency, and leverage all at once.
Chapter 12: Will AI replace programmers or create more of them? Every major technological shift eventually reduces itself to a single human fear: am I still needed? Cursor forces that question directly into the heart of software engineering. On one side, there is undeniable evidence of automation. According to studies of AI coding agents, systems like Cursor and similar tools can independently generate features, fix bugs, and participate in pull request lifecycles with measurable effectiveness across large datasets. Some workflows already show AI agents initiating the majority of development actions, while humans remain primarily in approval roles. That is not augmentation in the traditional sense. That is delegation. But on the other side, something unexpected is happening. As reported in developer research datasets, AI coding tools tend to increase total software output rather than reduce the number of developers working on problems. When building becomes faster, teams do not simply shrink, they expand scope. They attempt larger systems. They ship more features. They experiment more aggressively. This creates a strange dual reality. Individual tasks become more automated, but total engineering demand expands. However, even optimism has limits. Recent industry criticism warns that AI-generated code can introduce instability, technical debt, and security risks when developers over-rely on automated systems with rigorous oversight. The concern is not just replacement, but erosion of craftsmanship. So the future developer is unlikely to disappear, but their role is shifting shape. Less typing, more steering. Less implementation, more orchestration. Less writing code, more deciding what code should exist in the first place. In that future, tools like Cursor are not replacing programmers, they are changing what it means to be one. And the final question is no longer whether AI can code, it is whether humans will still recognize the act of programming when most of the code is no longer written by human hands at all.